Anybody? Don't you get a?
Is it the M+1?
No, the M+1 is the isotope peak for your parent. So your parent, whatever your parent is, the M+1 is the parent plus one. So the parent is 100, M+1 is 101. But the radical cation is what undergoes fragmentation. Remember your molecule is, we had this example, right? Because the first thing that happens is you bombard your sample with an electron beam and you eject one electron. So that's how it becomes cationic, right? So that radical cation is that's what gets broken into pieces. All right, let's look at number 2. What question does mass spec answer about a molecule?
The molecular weight.
Good. Right. All it tells you about is molecular weight and size. It doesn't tell you anything about the carbon hydrogen framework. That's what NMR is for. It doesn't tell you anything about pi systems. That's what UV is for. All right. So NMR does this. UV. Right. Tells you about the pi systems. Molecular ion effect is just a dummy answer. It's not an answer for that question. All right. Which of the following cleavage patterns do amines undergo? What was the last thing we talked about on Wednesday?
We talked about the different patterns of we talked about different patterns. So it was like the parent, the base, and it was one other one.
But then we also talk about where fragments, like where the molecules break up.
Yes.
And one of these is one of the patterns that molecules with different functional groups undergo, right? We talked about that. Let me scroll back up. Scroll up or down, sorry. What's that example?
Did we talk about that in the PowerPoint?
Yes. We did. It's not on here, but it's alpha cleavage, right?
What is what is the hemolytic cleavage? What is that?
Nothing.
Oh, okay. I was like, what does that even mean?
It's a throwaway answer.
Got it.
You got it. But if you know the different patterns, you know that that's not one of them that we talked about, right? And then this is one here that's thrown in, right, where it says heterolytic, because you can break a bond heterolytically, but the specific type of cleavage that we talked about is alpha cleavage. So this is a throwaway answer. And so is that. All right, so down here, let's look at the examples here. So you got an alcohol functional group. You have a ketone functional group. So what do you think about the cleavage patterns here, right? And I intended to upload that that PowerPoint. I'll upload it today with these notes, right? This is going to undergo alpha cleavage. Right, and it's you'll break here. Not at the same time, 2 separate events. And then you can also cleave here. That's alpha. and here. And one of the common mistakes when looking at mass spec is when you cleave that, let me show you what actually happens, right? Get a different color pen. So right here, this bond is breaking. You following? And so it's this carbon right here. That's a 3-carbon chain. And then everything else over here is going to be your other fragment, right? So normally if you have a alkyl fragment like this, you can make that your radical. And then this over here can be the cation. Y'all following that?
Yes.
Mm-hmm. And it's the same thing on the other side. Let me do this. How do I do this? Let me go back and undo what I did and copy that. I should copy it from the jump. Let me do this real quick. So I'm gonna right. So if these are my functional groups and I want to do alpha cleavage, I'm going to cleave here. Let me do that again. So I'm going to take that bond out. All right. So those are my 2 fragments. If I do alpha cleavage on the other side of the alcohol, then this bond is breaking. Right. So those are my 2 fragments. So that's how you go about the fragmentation pattern. It says draw the fragments and give their masses. Right. So this carbon right here, you have to remember this because that'll throw you off. This is that's a CH2, right? And this carbon right here is a CH. So when you're calculating the masses and adding up the atomic mass for each atom, you have to remember that, you broke a bond, that bond there, but there's still a hydrogen on that carbon and the other carbon, and the three carbon chain is a CH2. All right, same thing down here, right? This is a CH. And then this is a CH2. Otherwise, your masses are going to be off when you have to add up the mass of each fragment. Are y'all following that? Does that make sense? Any questions about that?
So wait, can you repeat that last part again about, okay, so you're saying that there are 2 ways that we can do this. We
Yes.
can, but oh yeah, you're gonna have to repeat it again. You lost me.
Yeah, so you can do alpha cleavage on either side of that functional group. Right, so what I have shown are the 2 sets of fragments that you'll get. Right, because keep in mind the original molecule right here, this, once it becomes the radical cation, is what's going to get broken up into pieces, right? So if I'm doing alpha cleavage on this side, on the left side of that alcohol right here, then those are the 2 fragments that I get. And one will be the radical, and one will be the cation.
And then you said when it comes to like picking which one's the radical and which one's the cation, usually if you have a carbonyl group, that would be the carbocation.
Yes.
Okay. And then with picking the radical, you just need to make sure it can, no. When picking the carbon cation, you just need to make sure that it can perform resonance.
Or be stabilized in some other way, yes.
Okay, got it.
So like right here, this would be my cation. And the alkyl chain would be my radical. Right, same thing over here. That's that, and that's that. All right,
Okay.
so yeah, so what I'm gonna have you do on your own is to determine the masses, right? The mass of the overall compound and the mass of the two fragments. My suggestion is to do the smaller fragment and then subtract it from the total. That's how you can get the other fragment really quickly. Let's look at the other molecule over here. And hold up, before we do that, let me paste this again. Right, the other functional group, the ketone, you can do the same thing. Let me paste it twice. Right, so with that ketone, it's the same thing. I can break this bond right here. That's alpha cleavage. Or I can break the bond on the other side like that. That's also alpha cleavage. Right, so I'm going to get those 4 fragments in the mass spectrum. So if I had a mass spec of that compound, those 4 fragments are all going to show up in addition to the parent, which is the molecule before you fragment it. Right, so I'm going to let me put that up here. So you want to calculate the masses of all of your fragments. Right, and you can do the same thing for put this on another page for this molecule right here. Right, where are your cleavage sites going to be here?
You can cleave on like the end of the OH group, the inside of the, yeah.
Okay.
And then on the other side as well.
Like that?
Mm-hmm.
And it'll be the same thing for the amine, right?
Yeah.
All right. So this one I'm going to leave.
What determines where you cleave off at?
Well, there are like certain patterns that these molecules are going to follow. So here we're just doing alpha cleavage. So alpha cleavage, once you find a specific functional group, like an alcohol, an amine, a ketone, you just cleave to the left and to the right of that functional group. Those are alpha cleavage patterns. All right. So if you have a branched alkane, then you're going to cleave at the branch points. If you have an alkene, you're going to cleave at the allylic site. Right. So those are the patterns that we follow in order to determine like where to cleave and where to cut the molecule. Did that answer your question?
Yes, thank you.
Okay.
Okay, but where else could we cleave if those are the only 2 functional groups?
Functional group?
Yeah.
Well, there are other patterns, right? But this question, I think, just asks for alpha cleavage. But you can cleave like really anywhere with a chain that long. You can chop this thing up a lot of different ways. All right, you can literally cleave anywhere on that chain. But in this particular case, we're only looking at alpha cleavage. Yeah, but with a chain at length, you can slice it and dice it. You're gonna have a lot of fragments. That mass spec is gonna be pretty messy. But one thing you will have for certain are the 4 fragments that come from that alpha cleavage, the parent and the M+1. That's without question. all the other stuff, you might have a bunch of different little fragments in there based on cleavage along that alkyl chain. But the 4 alpha cleavage fragments, the parent and the M+1 peak is guaranteed. They're all guaranteed. All right. Did that answer your question?
Yes, thank you.
Okay. All right. So I want you to work on that second example, and then I want you to work on calculating the masses for the first example. Man, I should have put this. I think when I post the notes, I'm going to put this on a separate page so it won't be all jumbled up. So yeah, let's keep moving. Unless there are other questions, let's go to this question right here. This is an infrared question, and it's asking. It says choose an absorption value that matches the indicated functional group shown below. So here's a ketone, it's circled, so that's how we know what functional group we're looking at. Which one of those absorbances do you think is going to be representative of a ketone stretch or a carbonyl stretch? So that's what we're looking for.
Is it the 3500?
3500. Are you sure about that?
No.
We the 3500. Which functional group is going to show up there out of these ones that are indicated here?
OH.
The OH group. All right. What about the CO sigma bond? We actually talked about that on when we finished that last NMR example, I think. That's going to show up somewhere between 1,000 and 1,200. So 1150 would be the closest value for that. The carbonyl stretch. Let's go back up to here because we've seen that already. What is right here? Can you see that when we did the NMR? We were talking about the NMR for this unsaturated ketone right here. And we said that in the infrared, that was a stretch at 1700, right? Your carbonyls are all going to show up in the range between 17 and 1800. Excuse me. All right, 17 and 1800. That's where your carbonyls are going to show up. All right, so if we go back down to here, right, we only got one stretch that'll match that, and that's this one. Right, and then the alkene stretch, a lot of times that'll overlap with the carbonyl because sometimes it'll show up in the same area. So this will be in alkene stretch, and that's going to be here. Right? How many of you watched the infrared video that I sent? Well, don't raise your hand. No mind. It's Friday. I don't want to put you on the spot. But that in that infrared video and in the examples that we've done, we've talked about each one of these stretches, with the exception of maybe the alkene stretch. But that's in the video. All right. So we've just been kind of weaving in infrared along with the other spectroscopic techniques. But yeah, all of the stretches are listed. There's actually a slide in that video, if I'm not mistaken, with all of your stretches listed on it, like all of the, and all the major stretches are discussed. So carbonyl stretch, alkene stretch, nitrile stretch, alcohol stretch, amine stretch, CO sigma bond, all of that stuff is discussed in detail with examples of where they would show up. So if you haven't watched that, maybe you should. All right, let's go to the second question. It says, it's actually the last question. It says calculate the molecular weight of each of the following molecules. So that's the first part. I'm gonna break y'all out and let y'all work on this for about 10 minutes, 15 minutes. Give the M+1 value. So you know that that is the, whatever the mass is, plus 1. And it says give the fragments that you would expect from each of the following molecules. So here, you got different functional groups. Like here you have alkene, right? So if you have an alkene, you can expect allylic cleavage. You got a ketone here, so you can expect alpha cleavage. And then you have a hydroxyl group here, so you, and alcohol. So that's going to be alpha cleavage. Right, you have the chlorine here too, so that's like that's a functional group that where you would expect to see alpha cleavage also. All right, so if you don't have the handout, which you should by now, because we've been working on it for over a week, take a screenshot of that, however you want to do it, and then I'm going to break you all out